Google's introduction of VEO2, VO2, is a game changer not only in changing the nature and quality of video image generation, which it does, and it is certainly the leader at the moment, but it also presages a new era in AGI. It's not AGI, okay? It's not artificial general intelligence. It may become a component of artificial general intelligence, AGI. But that's not what we're really addressing here. What really interests us is that it changes the way in which we're thinking about and approaching AGI. Let me just set the context with you for a moment, and let me introduce myself to you first if we haven't met before. I'm Dr. Aliana Moren, founder and chief scientist with Themesis Incorporated. We're a boutique AI research and also education company. I'm the founder of the Themesis Academy, which does include our educational offerings. And I'm an AI and neural networks researcher for at least the last 40-odd years, 4 patents. I've been teaching for nearly a decade at Northwestern University's Master of Science program in data science, where I've developed curriculum for the 2 core AI classes in the AI specialization, and also developed the curriculum for the AI-oriented capstone course. So my background in AI goes back a very long ways. But right now we're looking at a new horizon, and what we're going to discuss in these next few moments will be how is it exactly that Google's VEO2 is such a game changer? Why is it such a big shift? So the reason that VEO2 is such a game changer is simply this. It introduces a second level of representation into what was previously a pure generative approach. So quickly, generative is going to be a probabilistic generation of next step and then next step and next step, each one based on what just happened before. It can be language, it can be video, it can be image, it can be code, but it's all based on probabilistically what you just had. Generative algorithms operate at a single level of representation. That is, they're working with signal streams, but they don't have an object model in the sense of an aboutness of what that particular thing that they're representing, so to speak, really means. They don't have embedded ontologies. They don't have explicit associations of object attributes with objects. In other words, there's a whole lot of symbolic representation missing, just simply missing from a generative approach. Yet ever since, not just the introduction of transformers beginning in 2017 with Vaswani et al., but well before then, when Hinton did his breakthrough work, we're talking 2006 approximately, Hinton and Salakutinoff on their paper that introduced deep learning, and then of course 2012, Salakutinoff and Hinton, a more comprehensive paper, and by that time there was widespread knowledge of, adoption of, working with deep learning models. But deep learning models, again being generative, simply carried the signal level up higher and higher levels without having explicit object representation. They had extracted features at progressively more abstract levels, and that could result in an object characterization entirely coincident with Hinton's work in deep learning. We had Jan LeCun's work with convolutional neural networks, and he set the foundations for CNNs, but of course he didn't become practical and realizable until 2012 timeframe. And that you'll probably remember Ilya Sutskever, Alex Krzyzewski, under Hinton's guidance, they were doing the AlexNet, big breakthrough in image classification. Fabulous breakthrough, okay. But what that did, the combination of these two approaches, CNNs using backpropagation, just propagating it way down the ladder, and of course more interesting things that you could do with the various layers, and then deep learning, basically Boltzmann machine methods, but each layer is typically a feature extraction layer using the neural network method, essentially auto-associative Boltzmann machine filling in the blanks to identify features. So what that did, both approaches in tandem, in parallel, was they shifted our way of thinking. And we went from the earlier approaches where we were very explicit about delineating different levels of representation. Some of you, if you're old hands at the game, or if you're very well read in the literature, you might remember things like Mars 2.5D representation. This is 1980s work. Grossberg, I believe he was working with Mengola on this, and also I believe with Poggio. Beautiful work on vision, on early vision, and moving towards abstractions. And they were introducing very specific levels of representation. And the idea was you would move from a signal level, pixels in the image, so to speak, up to a syntactic, the relationships between things, which are now, of course, encapsulated in a lot of neural network processing. But there were some beautiful ideas back then. And then moving from there up to a object level representation. And presumably there would be feedback and communications between these different representation levels. But that all got subsumed from explicit representations into implicit representations when we moved into the neural networks approaches. Beautiful work, okay, absolutely valuable, but now of course we understand the limits of CNNs, and we also, because we just pushed that boundary to its limit, we understand the limits of purely generative methods applied to generation in images and videos. Fabulous, because now we can step back and say, oh, the breakthrough happens because we're having two distinct representation levels. We've got what they describe as a physically realistic object model interacting with the generative method applied to, of course, the image generation, the actual pixel generations. And comparisons with other competing models have been so fabulously in favor of the physically based object models approach that there's no comparison. It's like the game is now a totally different one, and we see the value of having more than just simple generative, not just generative, but generative interacting with the physically realistic object models and a feedback going on. Now, the reason that's important is that physically realistic object models, they're representation level. And they are complicated. I mean, there's a lot that needs to get done to get those object models working well for all kinds of visual situations. So we're reintroducing that notion of explicit object models that interact with a generative signal level of processing. Breakthrough moment, because it reintroduces the value of having multiple levels of representation. Now, it's not an AGI precursor in the sense of we're not going to build an AGI strictly around that. What it is reintroducing a very long-lost way of thinking of having multiple representation levels and feedback and interactions that is going to be essential as you build AGIs, specifically from a signal level up to a very well-defined, robust world model and communications between those loops. So just a couple of notes here, because we're going to pick up on this in future YouTubes. Number one, huge implications for the companies that intend to lead in the AGI space, because it's clear that we're going to need more than just generativity. We're going to need a whole ontological world model, symbolic representation, which includes physical object models, and we're going to need to have the interactions with them. Signal level representation, symbolic level representation, interactions. That's a whole wealth of work that needs to be done, and it's going to require multiple disciplines. The people that work at the signal level, at the generative level, are not necessarily going to be the players who work at the symbolic level or those who work best with the feedback control loops. So there's going to be a sense of building new teams with new capabilities. And we're not even talking about reasoning, goals, controls at a more purposeful level. So the way that we've been approaching, for example, agent-based reasoning, which is narrow AI, we know that it's narrow. It's what Sun Tzu would describe as foraging off the land. It's getting some sort of cash revenue, some sort of systems built and out there, even if they're exceptionally narrow purposed, but they can be fielded and they can be used, and they can be revenue generation streams for the companies that are using them, while we get about the deep business of building AGIs. So there's going to be a huge shift in team composition, and that's also going to take time because people have to learn to talk with each other. We'll talk more about that later. The other thing is that it really shifts our notion of AI education. a lot of educational offerings right now, just being broad. Introduce what I call in that Oregon Trail of AI. There's a wealth of offerings at the prairie grass level, the simple things, backpropagation, CNNs, even reinforcement learning. They all belong there. They were all invented in the same era. Generative methods are more complex. Generative involves a fusion of three disciplines. You minimally need some Bayesian, a rough understanding of the Kullback-Leibler divergence, specifically the reverse Kullback-Leibler divergence, and then just enough statistical mechanics to get by. You need a little bit in order to understand where those equations take you. By the way, here at Themesis, we offer that requisite capability if you're going to educate yourself, if you're going to educate your team. Please stay to the end. I'll put just a few more words on that. But that describes the whole, we call it a generative AI mountain range, and the danger of getting trapped in the Donner Pass of generative AI where you don't know the definitions. You can't get through the whiteout storm of understanding all these different little elements and how they fuse together. And then that is a kiss of death for many who are attempting to be self-taught. But suppose you can get your people or yourself through that whole Sierra Nevada mountain range of generative AI. And by the way, there are two distinct Donner Pass elements within that, one of them being the neural networks elements, dominantly Boltzmann machines and transformers, although we throw in variational autoencoders. And then the other being the variational methods. They're both important, and if we're going to do AGI, we need a comprehensive understanding of both. But then you get to the other side, and life is more than LLMs. In other words, it's more than just an LLM, more than just an LLM with a reinforcement learning engine bolted on top, more than just narrow agentic AI, although that's what we've got right now. It's going to be more, I know that this is piling it up here. It's going to be more than Jan LeCun's JEPA, Joint Embedding Predictive Architecture, or even his hierarchical JEPA, or his image JEPA, or his video JEPA. It's going to be more than Carl Friston's active inference, which is an outgrowth of variational inference, and even more than Friston and his group recently having developed renormalization generative models, RGMs, which are hierarchical tiers of active inference capabilities. Both the active inference and the JEPA being useful for planning, but not enough in themselves, and not linking as directly as we'd like to symbolically oriented world models. So there's still something that yet needs to get built if we're going to go AGI. And I've talked about that in previous vids. I'm going to hold off and not even mention it here because I want more time to be spent on that. But suffice to say, there are new capabilities that need to get developed. Now, though, people will start thinking about them intelligently, creatively, thoughtfully, and say, well, you know what? We've gotten as much as we're going to get out of simple generative methods. Adding more billions of elements in our queue and trillions of connections, it's just not going to buy us a whole lot more. And we'll still have the same old problems. So let's think about something different. So AI education, it's going to take a totally new meaning as we expand our notions of what it is that we need to put into our educational portfolio to be ready for this. Whatever your role, whether you're planning your own education or if you're a corporate leader at the CXO level and you're saying, how do I need to guide my teams, evolve my teams, move my teams towards the AGI goal now that we realize it's not just generativity anymore? There's some things that are well worth attention right now. Number one is that basic education in generative. And I don't mean prompt engineering for chat GPTs. No, I really do mean those fundamentals, the theoretical foundations, understanding how they contribute to all aspects of generativity. Second, getting your people qualified in the outer edges, the Friston, the LeCun thinking that are where we are at the edge of generativity right now. A little bit of work with reinforcement learning is not bad. It's not a bad use of time, whether you're a student or you're planning corporate goals and trying to move your corporate teams in certain directions. It's not bad, but it's limited. It's not going to carry us far. I do suggest looking at more advanced symbolic models, which we will address, control methods for addressing the communication between signal and symbolic models, and some of the more advanced ways of moving around in that play space where you want to do something beyond just simple reinforcement learning as your only methodology of choice. And please, to follow up, to get material that bolsters today's discussion, use the discussion box below. Click on the link to go to the blog post. From the blog post, you're going to get all sorts of very good links, and typically we try to put together paired YouTubes and blog posts where they're essentially like little mini classroom sections where the lecture, so to speak, is what we've just had right now, and the blog post is your reading material with all those links that you need to support your further endeavors. I'm going to ask that you look into the Themesis Top 10 Terms in Statistical Mechanics course, the easiest, fastest, most direct way of educating yourself in that element that is very, very difficult to teach yourself on your own. And finally, to be assured that you get the next installments in this discussion series, go to the themesis.com website, go to the About page, click on that, scroll down, find the opt-in form, do the opt-in thing. Move the confirmation email over into your preferred inbox and start opening and clicking on those emails, because over these next few weeks and months we'll be carrying these conversations more deeply. And if you subscribe to us on YouTube, which of course I would love it if you did, we would all love it if you did, very useful, but you might miss a thing or two. So emails where we announce the YouTubes, the blog posts, study resources, course opportunities, anything that we offer that'll be useful for you as you move beyond generative into real AGI. Thank you once again. Aliana Moren from Themesis. Have a lovely day. We'll see you soon.